Dear students, under the topic vector differentiation, we are going to learn about how to find the equation of the tangent plane to a given surface at a given point. So the equation of the tangent plane to the surface phi of x comma y comma z equal to c1 at the point a comma b comma c is given by dot product of r vector minus r1 vector with p vector is equal to 0. So this gives us the equation of the tangent plane. Now what is the r vector over here? It is the position vector given by xi vector plus yj vector plus zk vector. And r1 vector is the vector that is obtained from this given point, that is ai vector plus bj vector plus ck vector. And what is this p vector? P vector is nebula phi. So this is r vector, this is r1 vector, and p vector is nebula phi. When we subtract r1 vector from r vector and take a dot product with this p vector and equate it to 0, we get the equation of the tangent plane. Now let us solve problems under this topic. So now here we have a problem where we have to find the equation of the tangent plane to the ellipsoid x square plus 2y square plus 3z square equal to 6 at the point 1 comma minus 1 comma 1. Now if you see, the given point is taken as a comma b comma c. So the value of a is 1, b is minus 1 and c is 1. Now we have to find the equation of the tangent plane. We know that the equation of the tangent plane for a given surface phi is given by r vector minus r1 vector dot product with nebula phi is equal to 0. This nebula phi is also represented as p in the formula. So I have directly written what is p. So what is r vector in this? It is the position vector given by xi vector plus yj vector plus zk vector. And what is this r1 vector? R1 vector is the vector obtained from the given point, that is ai vector. What is a? A is 1. So I vector plus bj vector. What is b? It is minus 1. So minus j vector. And then plus ck vector. What is c? C is 1. So plus k vector. So this is r vector. R1 vector. Now we have to find nebula phi for the given surface. So this is the given surface. First we shall rewrite this surface as a function of phi. So therefore we obtain phi to be equal to, so from this we have x square plus 2y square plus 3z square, and bringing the 6 to the left it becomes minus 6. So this is phi. Now using this phi, let us find nebula phi so that we can substitute over here. The nebula phi is given by dou phi by dou x I vector plus dou phi by dou y j vector plus dou phi by dou z k vector. Now we shall substitute each of this over here. That is, we have phi. So let us differentiate phi partially with respect to x and substitute here, partially with respect to y and substitute here, and partially with respect to z and substitute here. So from this phi, we see that dou phi by dou x is equal to, so if you differentiate this partially with respect to x, here alone you have x. So all this will be treated as constants and they will become 0. And what is the differentiation of x square? It will be 2x. In a similar manner, dou phi by dou y we have to find. That is, we have to partially differentiate this with respect to y. And so x square, 3z square and minus 6 will be treated as constants. And on differentiation they become 0. And the differentiation of 2y square will be, the differentiation for y square is 2y. And when it gets multiplied with this 2, it becomes 4y. And then we should also find the differentiation of phi with respect to z partially. So when we do so, x square 2y square and minus 6 becomes 0, and the differentiation of 3z square will be, that is, the differentiation of z square is 2z. When it gets multiplied with 3, it becomes 6z. So we have found all these three. So let us substitute in this nebula phi. So nebula phi will be equal to, what is dou phi by dou x? It is 2x. So 2xi vector plus dou phi by dou y is 4y j vector plus dou phi by dou z is 6z k vector. Now we have to find nebula phi at the given point. So nebula phi, what is the given point? The given point is 1 comma minus 1 comma 1. So at that point we have to find. So 1 comma minus 1 comma 1. And so that will be equal to, at the place of x we have to substitute 1, at the place of y we have to substitute minus 1, and at the place of z we have to put 1. So when we put x as 1 over here, it becomes 2i vector. And for y it is negative 1. So when it gets multiplied here, it becomes minus 4j vector. And plus, here z is 1, so it becomes 6k vector. So therefore we have found nebula phi. Now we shall substitute all this in order to find the equation of the tangent plane in this formula. So I have taken and I have written the equation of the tangent plane is given by this. Now we shall substitute in this. That is, what is r vector? We know that r vector is xi vector plus yj vector plus zk vector minus r1 vector. What is r1 vector? We have already written here. We have r vector, r1 vector. So I vector minus j vector plus k vector. So let us substitute that. So I vector minus j vector plus k vector. And this has to be taken dot product with nebula phi, which we have found here. So it will be 2i vector minus 4j vector plus 6k vector, and that is equal to 0. Now if you see, we have to subtract this vector from this. So the subtraction has to be done component wise, that is x minus, here we have 1. So it will be, if you see, x minus 1 I vector, and then y, this one minus into minus will become plus. So y plus 1 j vector. So y plus 1 j vector, and then z minus k, 1. So it will be plus z minus 1 k vector, and this has to be taken dot product with 2i vector plus 4j vector plus 6k vector is equal to 0. So when we take the dot product, we should take the product component wise. So x minus 1 multiplied with 2. So it will be 2 into x minus 1. And then y plus 1 multiplied with 4. So plus 4 multiplied with y plus 1. And z minus 1 multiplied with 6. So plus 6 multiplied with z minus 1, and that is equal to what? It is 0. And this is negative 4, okay, because we have negative 4 over here. By mistake I have written plus, this is negative 4. And so when y plus 1 is multiplied with negative 4, you will have here also minus. So kindly make that correction. And then after this, you multiply 2 within the bracket. So 2x minus 2 and minus 4 within the bracket. So minus 4y, and then minus 4 plus 6z, and then minus 6 is equal to 0. Now from this, what you will obtain? First you write 2x and then minus 4y and then plus 6z. Okay, and what about the constants? It is minus 2, minus 4, minus 6. So we have to add all of them. It will become minus 12. So minus 12 is equal to 0. So this gives us the equation of the tangent plane. Now if you see, 2 is common in all the terms. So we can divide this equation throughout by 2. So on dividing the equation throughout by 2, what we will get? X minus 2y plus 3z minus 6 is equal to 0. So this gives us the equation of the tangent plane for the given surface. So I hope by now you must have understood how to find the equation of the tangent plane for a given surface at a given point. We will solve one more problem on this same topic so that you understand it more better. So now here we have another question where we have to find the equation of the tangent plane to the given surface at a given point. Now we know that the equation of the tangent plane is given by r vector minus r1 vector taken dot product with nebula phi equal to 0. What is this r vector and r1 vector? R vector is given by the position vector xi vector plus yj vector plus zk vector, and r1 vector is the vector obtained from the given point, which is 3i vector plus 2j vector plus k vector. Now in order to find the equation of the tangent plane, we have to find nebula phi. So the nebula phi is obtained from the given surface. So let us take and write this given surface first. So we have taken and written the surface. We know that nebula phi is given by dou phi by dou x I vector plus dou phi by dou y j vector plus dou phi by dou z k vector. Now we shall find each of this, that is dou phi by dou x, dou phi by dou y and dou phi by dou z from the given surface phi. We see that from the given surface dou phi by dou x is equal to, we have to differentiate this partially with respect to x. So all these terms become 0 and we get 2x. In a similar way, dou phi by dou y, we have to partially differentiate this with respect to y. So all these terms become 0 and the differentiation for y square is 2y. It gets multiplied with negative 4 and so we get negative 8y. And then we have to find dou phi by dou z, which is equal to the partial differentiation of phi with respect to z. So all these three terms become 0 and the differentiation for z square is 2z. When it gets multiplied with 3, it becomes 6z. So now we shall substitute all this over here. So we get nebula phi to be equal to dou phi by dou x is 2x I vector, and then dou phi by dou y is minus 8y. So minus 8y j vector plus dou phi by dou z is 6z k vector. Now we have to find nebula phi at the given point. So what is the point given? It is 3, 2, 1. So at this point we have to find. So 3, 2, 1. So x is 3, y is 2 and z is 1. So that will be equal to, so when we put x as 3, we get 6i vector minus y as 2, 16j vector, and z as 1, we get plus 6k vector. So this is nebula phi. Now we have r vector over here, r1 vector and nebula phi. So we can substitute in this equation of the tangent plane. So when we substitute, we get, what is r vector? We know that it is xi vector plus yj vector plus zk vector minus r1 vector. What is r1 vector? 3i vector plus 2j vector plus k vector. So let us substitute that. So 3i vector plus 2j vector plus k vector. Now this has to be taken dot product with nebula phi. Now what is nebula phi? This is what we have obtained. So 6i vector minus 16j vector plus 6k vector. Now first we will do this subtraction. So that will be, and this is equal to 0. So on subtracting we get x minus, here component wise we have to do the subtraction. So x minus 3 I vector. Next we have y minus 2. So plus y minus 2 j vector plus z minus 1. So z minus 1 k vector. And this has to be taken dot product with 6i vector minus 16j vector plus 6k vector, and this is equal to 0. So when we take the dot product, we have to multiply component wise. So this will be 6 multiplied with x minus 3, and then here y minus 2 has to be multiplied with minus 16. So minus 16 y minus 2, and then 6 has to be multiplied with z minus 1. So plus 6 into z minus 1 is equal to 0. Now we shall multiply within the bracket. So 6 minus 18 minus 16y, and minus into minus will become plus 32 plus 6z minus 6 is equal to 0. So now we can write the 6x first. and then minus 16y, and then plus 6z, and we can combine the constants minus 18 plus 32 minus 6. So minus 18 minus 6 gives us minus 24. So 32 minus 24 will give us 8. So plus 8 is equal to 0. Now if you see in all these terms, we can divide this by 2. So when we divide this equation by 2, we get 3x, and here minus 8y, and here 3 again. So plus 3z, and then plus 4 equals 0. So this gives us the equation of the tangent plane for the given surface. This is a significant problem in the examination point of view. So hope you have understood how to find the equation of the tangent plane for a given surface at a given point. So kindly follow the next video lecture to find the angle between two surfaces. The angle between two surfaces, and also to learn about the concept that when two surfaces can be orthogonal to one another. Thank you.